everyone, here is Afra. Today we are going to solve Cambridge IGCSE Physics 4 Paper Theory Extended, held on February-March 2021, and paper code is 0625 with variant 42. So let's start from question number 1. Here is question number 1, part A. Figure 1.1 shows a piece of glass of thickness 2.0 cm and area 0.15 meters square. The density of glass is 2.6 into 10 to the power 3 kilogram per meter cube. Calculate the weight of the piece of glass. Here we have to calculate weight. We know that weight is the product of mass and acceleration due to gravity. And we know that g is equal to 10 meter per second scale, but we don't know the value of mass. We have to calculate the mass. And in the question it is given that density is 2.6 into 10 to the power 3. So density is also equal to mass per unit volume. From that, if we know the volume, we can easily calculate mass. Mass is equal to product of density and volume. Density is given in the question and we have to calculate volume, and we just multiply thickness with area to calculate volume. So I write here thickness multiplied by area. Thickness is given 2.0 cm. We have to convert this into meters. So I write 2.0 over 100. It will be equal to 2.0 into 10 to the power minus 2. Multiply by area is 0.15. So volume is equal to this value meter cube. And now I put this value in this equation. So M comes to be density is 2.6 into 10 to the power 3 multiplied by 2.0 into 10 to the power minus 2 and 0.15. So mass comes to be 7.8 kilogram. We have put the value of mass in this equation to calculate weight. So weight will be equal to 7.8 multiplied by 10. So it comes to be 78 newtons. The weight will be equal to 78 newtons. Part B. The piece of glass shown in figure 1.1 is used as a vertical viewing window of an aquarium. The atmospheric pressure outside the aquarium is 1.0 into 10 to the power 5 Pascal. The average pressure on the inside of the aquarium window is 1.3 into 10 to the power 5 Pascal. Calculate the resultant force acting on the window due to these pressures and state the direction in which it acts. So, when this aquarium is in vertical position, it will be just like this. I use ruler to draw this. So it is the vertical position of this aquarium window. So there is a pressure that is atmospheric pressure and it is exerting in this direction. It is the pressure due to the air, P atmospheric, and its value is given 1.0 into 10 to the power 5. 1.0 into 10 to the power 5 pascals. The average pressure on the inside of aquarium. Inside there is the water and the pressure of this aquarium is in this direction and its value is 1.3 into 10 to the power 5 Pascal. Here we have to calculate the resultant force and we know that P is equal to F over A. By using this formula, F comes to be pressure multiplied by area. Here this force is the resultant force. It means that we have to calculate the resultant pressure first. So in this figure you can see that both the pressure that is inside the aquarium and the atmospheric pressure are in opposite direction. That's why I can find out the resultant pressure by subtracting them, and it comes to be 1.3 into 10 to the power 5 minus 1.0 into 10 to the power 5. So it comes to be 0.3 into 10 to the power 5 pascals. I just write here 0.3 into 10 to the power 5 pascal, and area is also given, which is 0.15 meters square. So after multiplication I get force comes to be 4500 newtons. So I write here force is 4500 newtons. In the question it is said that we also have to state the direction in which it acts. So we know that there are two pressure. First is atmospheric pressure and second is the pressure inside the aquarium. So the pressure acting due to the water is greater. This pressure is greater as compared to the atmospheric pressure. So the direction of pressure will be outward. So I write here the direction is outward. As the direction of pressure is outward, the force will also be outward in direction. So I write here outward. Next part C. Figure 1.2 shows a vacuum pump connected to the top of vertical tube with its lower end immersed in a tank of liquid. So here is a tube and its one end is immersed in the tap while the other is connected with the vacuum pump. The pump reduces the pressure above the column to 0. It means that at that point pressure is equal to 0 and the pressure at point X at this point means that at this level the pressure is 9.6 into 10 to the power 4. So I write here pressure is equal to 0 and here pressure is equal to 9.6 into 10 to the power 4 pascal. Calculate the density of the liquid. So here we have to calculate the density and we know that here both two pressures are given and there is also a height which is given 12 meters. So we know that delta P, that is the difference in pressure, it will be equal to rho G delta H, where rho is density, G is acceleration due to gravity and delta H is difference of height. So here we have to calculate density. It will be equal to delta P over G delta H. So delta P is difference in pressure. It will be 9.6 into 10 to the power 4 minus 0. At that point pressure is 0 divided by the value of G is 10 and delta H is 12. The difference of height. So density comes to be 800 kilogram per meter cube. So the value of density comes to be 800. I write here 800. The unit of density is kilogram per meter cube. Question number 2. A. Part 1. State what is meant by moment of force about a point. So here we have to define what is meant by moment force. So it's a 1 mark question. We just start its definition that the moment of force is actually the turning effect of force about a pivot point. So I write here turning effect of force about a point. Part 2. Figure 2.1 shows a large crane on a construction site lifting a block of mass 14,000 kg. So it's a block and its weight is 14,000 kilogram. Calculate the moment about A. Due to the 14,000 kilogram blocks suspended from B, here are 2 points B and A. The distance between these 2 points is 20 meters and we have to calculate the moment about point A that is produced due to the block which is suspended at point B. So first of all we know that moment is equal to the product of force and perpendicular distance from pivot. So I write here F, I represent it with D, so it will be equal to F cross D. But here we don't know about force. First of all, here the block weight is acting in downward direction and in this case the weight is actually equal to force and we know that weight is equal to product of mass and acceleration due to gravity. That's why I write here force is equal to weight cross D and mg cross D. Mass is given that is 14,000 and value of g is 10 and the distance between the point A and B is 20 meter. So I write here 20 and the moment comes to be 2.8 into 10 to the power 6 Newton meter. It's the value of movement about point A that is produced due to the block. So I write here moment is equal to 2.8 into 10 to the power 6 Newton meter. Part B. Speed is a scalar quantity and velocity is a vector quantity. State the difference between the scalar quantity and vector quantity. Scalar quantity is the quantity that has only magnitude. I write here scalars has only magnitude, but vector quantity has both magnitude and direction. This is the main difference between both of these. So I write here scalar quantity has only magnitude and vector quantity has both magnitude and direction. Part 2. Write down one other scalar quantity and one vector quantity. Scalar quantity has only magnitude like time and displacement. So I write here time displacement. Both of these are scalar quantity. So the distance is a scalar quantity. Displacement is a vector quantity because it has specific direction. So I write here distance. While displacement is a vector quantity, and force is also a vector quantity. Next part. So part C, figure 2.1 shows two forces acting on the object, and the 20 Newton force is acting vertically downward while the 30 Newton force is at angle 60. And 20 Newton force has only vertical component, that is y component, and 30 Newton force has both vertical and horizontal components. That is 30 Newton force has x and y components, while 20 Newton has only y component. Draw a scale diagram to determine the resultant force acting on the object. State the scale you use. So here we have to draw the resultant force, that is the resultant of 20 Newton and 30 Newton. First of all, I use a scale that 1 Newton force is equal to 1 centimeter. Here is 10 Newton is too much small scale, so I let that 10 Newton is equal to 1 centimeter. Here is 20 Newton and 30 Newton. So 20 Newton will be equal to 2 centimeter and 30 Newton will be equal to 3 centimeter. So first of all, here is a force F1, that is 20 Newton, and it is acting downward direction, while the second force is acting at angle 30 in this direction. So when I draw the resultant, by proper scaling, it will be just like so. Here I consider I have drawn a line of 2 centimeter. It is 2 centimeter and its magnitude is 20 Newton. Secondly, we have to draw the second force, that is 30 Newton, at angle 60. So by proper by using protractor, you can find out the angle, that is 60. It's the correct position of this, and I have to draw the line from that point, that is 3 centimeter. So it will be just like this. It is 3 centimeter line. As force is a vector, we also have place arrow. It is 20 Newton and it is 30 Newton, and R it is equal to 2 centimeter and it is equal to 3 centimeter. It is according to head to tail rule. According to head to tail rule, the tail of second vector must lie to the head of first vector, and the direction of resultant will be from the tail of first vector to the head of last vector. So when I draw the resultant, then what will I do? I join the tail of first vector with the head of last vector. It will be just like this, which is the resultant vector. So basically, this angle, if I redraw this line, this angle is basically 60, degrees. And this is the resultant vector. We have to find out the magnitude of this resultant vector. So you can easily find it by using the scale. By using scale, the value of this resultant will be it is 1 centimeter, it is 2 centimeter, 3, 4, and it is almost 4.4. So the resultant magnitude is equal to 4.4 centimeter. We have to convert this into Newton, so I just multiply it with 10. 4.4 multiplied by 10, it comes to be 44. So the magnitude of the resultant force is equal to 44 Newton. So I write here scale I use here is that 10 Newton is equal to 1 centimeter and the magnitude of resultant is 44 Newton. We also have to find out the direction of resultant vector relative to the direction of 20 Newton force. It means that we have to calculate the angle of resultant with the 20 Newton force. We have to calculate this. And by using the protractor, you can calculate this angle and it comes to be 36 almost. So I write here 36 degrees. Anti-clockwise from 20 Newton force. 36 degrees in anti-clockwise direction. Question number 3. A power station burns waste materials from farm crops to generate electricity. Part A. State and explain whether this process is renewable. So first of all, the waste materials from farm crops, it is used to generate the electricity and the waste materials don't run out. And the farm crops, it is also can be regrown. So this is a renewable source of electricity. I write here yes. So we can use this process again and again. So it's a renewable. And explanation is that the crops can be regrown. Part B. The power station uses some of its waste thermal energy to heat water for houses in a nearby town. State one problem of using waste energy in this way if the power station is far from the town. So the waste thermal energy is used to heat the water for those houses that is a nearby town, but it's not used for the houses that are far from the town, because we know that if it's a power station and there is a waste thermal energy, to use this thermal energy to heat the water, and by this water, that is heat water, it is used in the nearby town. It does not cover too much distance, but the houses that are far from the town, the thermal energy is lost, or we can say that simply water will cool down. That's why this is the problem for using the waste energy if the power station is far from the town. So I write here water will cool down. suggest a way of reducing this problem. We can reduce this problem by insulate the pipes so that the temperature of water remains high. I write here insulate the pipes. Part C. State 2 environmental consequences of burning coal to generate electricity. So, here we have to describe the environmental consequence when the electricity is produced by the burning of coal. So, it causes air pollution. It causes air pollution. And second one is that it is not renewable. We cannot use it again and again to generate electricity. So these are the two environmental consequences when we generate electricity by the burning of coal. Question number 4. Part A. In terms of momentum of molecules, explain how a gas exerts pressure on the walls of container. So here if I consider a container and inside these gas molecules. These gas molecules are in continuous motion and they collide with each other and also with the wall of container. When I consider this molecule when collide with the wall of this container, it changes its direction and comes back in the opposite direction. So this change in direction causes the momentum change, and we know that force is equal to change in momentum per unit time. So change of momentum is actually associated with the force. When there is a change in momentum, the gas molecule exerts force on the wall of this container. So there will be the generation of force, and we know that pressure is equal to force per unit area. When there is a force, then the pressure exerted. It means that when the molecules collide, they change their direction and the momentum created there. And this change in momentum is associated with the force. The molecule exerts force on the walls of container, due to which there is also the pressure that is exerted by the gas molecules on the walls of container. So I write here, molecules attracts with wall of container. Momentum of molecule changes. And we know that as F is equal to rate of change of momentum delta P. So the molecule exerts force on the wall. And there will be pressure according to P is equal to F over A. So in this way the gas exerts pressure on the walls of container. Part B. A fixed mass of gas of volume V1 is at pressure P1. It is compressed to a volume V2 1. Complete the equation for the final pressure P2 of the gas when the gas is compressed at constant pressure. At constant temperature, here temperature is kept constant and we have to find out the final pressure. We know that here Boyle's law is used. According to Boyle's law, pressure is inversely proportional to volume and temperature is constant. By using Boyle's law, we write P1 V1 is equal to P2 V2 and we have to calculate the value of P2. It comes to be P1 V1 over V2. So I write here P1 V1 over V2, which is equal to P2. Part 2. State and explain how the final pressure compares with P2 when the temperature of gas increases during compression. So here temperature is not constant but it is increasing. And we know that when temperature increases, kinetic energy also increase and kinetic energy is equal to half mv square, due to which the speed also increases. By increasing the speed, the gas molecules collide with each other very fast and their collision will be very frequently, due to which pressure increases. Collide frequently and exert pressure on the walls. As a result, pressure increases. So I write here statement that pressure will be greater and molecules move faster. More frequent collision. Question number 5, part A. State the name of reflection of sound wave or ultrasound wave. So first of all, we have to know about the reflection. If I consider that it's the boundary, and sound wave coming in this direction falls on the boundary, then they come back but the direction is opposite. So the coming back of the sound wave after striking the barrier is known as reflection of sound, and the other name for this is echo. Part B. Figure 5.1 shows an ultrasound wave being used to scan an internal organ of body. So in the figure 5.1, these are ultrasound waves and this is the internal organ and this is ultrasound transmitter and receiver. The ultrasound wave has a frequency of 2.0 MHz and passes through the human tissue at a speed of 1500 meter per second. Calculate the wavelength of ultrasound wave in human tissue. Here we have to calculate the wavelength by using equation V is equal to F lambda. Here V is given 1500 meter per second and frequency is given 2.0 MHz. First of all, we have to convert this into Hertz. It becomes 2 into 10 to the power 6 Hertz. And we have to calculate wavelength. Lambda will be equal to V over F. By putting values, we get lambda comes to be 7.5 into 10 to the power minus 4. and the unit of wavelength is meter. So wavelength will be equal to 7.5 into 10 to the power minus 4 meters. In part C, there is a figure 5.2 shows crust of wave from a point source as approaching a straight barrier. So it's a barrier and the waves from the source is going towards the barrier. Part 1 on figure 5.2 indicate and label one wavelength. So we have to label that how much distance is equal to wavelength. So wavelength is defined as the distance between two consecutive crusts or trough. It is defined as the distance between two consecutive crusts or trough. So in the question, the crusts of the wave are shown. So these are the crusts, and we can simply say that the distance between these two crusts is equal to wavelength, and it is equal to one wavelength. Also the distance between this crust and this crust, it is also equal to one wavelength. So we can mention any one of these. Part 2. On figure 5.2, draw three crusts of the wave reflected from the barrier. So we have to draw the crust that was reflected by the barrier, and the barrier is a denser medium. Its density is very large. So when the crust falls on this, then its direction will be opposite, but its wavelength remains same. So when I draw the reflected crust of the wave, it will be just like this. And remember that the distance between these will also be equal to wavelength. So these are the three crests of the wave when these are reflected from the barrier. Question number 6, part A. Figure 6.1 is a full-scale diagram showing a converging lens. The two principal focuses F1 and F2 and an object PO. Here is object PO and the principal focus are F1 and F2. Here we are asked on figure 6.1, draw the two rays from point O of the object to determine the position of the image. Here we have to determine the position of image and draw two lines. Label the image IJ. Measure the length of the image. We also have to measure the length of image. First of all, we have to draw the lines. First ray passes through the center of lens. And second ray passes through the lens, and then after refraction passes through the focus point. First of all, pass through lens parallel to optical axis, and after refraction pass through F1. So first of all, I draw the rays. This is the first ray that passing through the center of this lens and goes straight forward. Second ray is that first of all it is parallel to axis, that is principal axis, and after refraction by the lens it passes through the focus point. So the point where they meet, it is the location of image, but we can see that the rays are moving apart from each other. These are not meeting at a point. So then we extend them in backward direction and find the location of image. As it is not real image because the lines are not meeting at a point, we extend them in backward direction and then forms the image. This kind of image is actually virtual image. So I extend these in backward direction. I also extend the second one ray. And the point where both of these rays meet, at that position it forms the image. So it is the location of image I. We have to label it with I and J. In the second part, we have to measure the length of this image. Again, we use the ruler and measure its length, and it comes to be 2.9. So I write here the length of this image is 2.9 centimeters. In the next part, we have to tell the nature of this image. Reading the 3 description of the image. So the image is diminished, it means that smaller image, but we can see here is the location of object. Size of object is very small as compared to image. So the image is larger as compared to object. So first is incorrect. Magnified. As the size of image is larger as compared to the size of object, so it is the magnified image. Real. It's not real image because this image is formed by extra extending backward direction. So it is not real image, it is the virtual image. And same size. The size of image and size of object is not same. So it's also wrong. The same way up as object. The direction of image is same as that the direction of object. So this one is correct. Upside down compared to object. So it is not correct because the direction of both are in downward direction. Part C. Here is figure 6.2 shows 3 rays of green light passing through the glass block. There are 3 glass blocks. It is first, second and third one. The 3 green rays passing through this glass block. 3 rays of red light approaches the glass blocks on the same path as the rays of green light. So now we have to replace these green light with the red light rays. So we know that green and red, the frequency of red is very small as compared to green, and the wavelength of red is very large as compared to green light. So I write here wavelength and frequency. Green light has small wavelength, but red has large wavelength. The frequency of green light is large, whereas red light has small. So here we can see that the green ray coming and passing through the glass block without any deviation, that is the central ray. If you consider this ray, that is first, it refracted by this glass block and bent. Similarly, the third ray refracted by the glass block and bent, and both of these rays meet at a point. We have drawn the same pattern for the red light, but the amount of bending or refraction depends upon the frequency. It depends upon frequency. And we know that for red light, the frequency is smaller as compared to green, so there will be less bending in the case of red light. So red light bend least. When we draw here for red rays, the central ray will be straight, it will not deviate. The first ray that strikes the glass block and gets refracted. There will be small amount of bending and it will be just like this. Similarly, for the third ray, there will be refraction by this glass block. And after that, ray move in this direction. So this is the path for the red light, and it bends very small amount as compared to green light. So we have drawn the path for these rays through the glass block. We also have placed arrows here to show the direction of rays. At that point, both rays intersect to each other. Question number 7. Figure 7.1 shows a horizontal conducting wire XY between two opposite magnetic poles. Wire XY forms a complete circuit with an ammeter. Part A. Explain why the reading on ammeter is 0 when the wire XY is not moving. So in the figure 7.1, there are two poles, north pole and south pole. These are the poles of magnet and it forms the magnetic field. We know that the magnetic lines of force points from north to south direction. So I am going to draw the magnetic lines of force there. It starts from the north pole and ends at the south pole. And to solve this kind of question, we have to know about the electromagnetic induction. What is electromagnetic induction? When there is no battery in the circuit, then there must be the current through the circuit. It means that without any battery, there will be current flowing through the circuit, which is known as induced current. And this phenomena is known as electromagnetic induction. So here you can see that there is no magnetic field in the figure 7.1, but still ammeter is connected there, which shows that the current passing if the wire XY moves. But in the question, it is said that the ammeter reading is 0 when XY is not moving. It means that the wire XY is at rest. And let's suppose that the wire is moving up and down. Then this wire cuts the magnetic lines of force at some point. It means that the magnetic lines of force are changing there. But when the wire XY is at rest, then there will be no cutting of magnetic lines of force, which means that there is no magnetic field changing. So I write here, that's why there is no current in the circuit and ammeter reading will be equal to 0. So I write here no cutting of magnetic lines of force. No cutting of magnetic field lines or magnetic lines of force. Both are same things. Part B. The wire XY is moving and there is a deflection on the ammeter. That indicates that there is a current in the wire from X to Y. So the direction of current here is from X to Y. On table 7.1, tick one box to indicate the direction of movement of the wire XY and explain your answer. So first of all, in this part, it is said that the direction of current is from X to Y and we have to indicate the direction in which the wire moves. So going back to the figure, I suppose that the direction of current here is from X to Y. So it means that the direction of current is this and the magnetic lines of force from north to south direction, and we have to find the direction in which this wire moves. So here I use the flaming rule. I write here flaming rule. For the application of flaming rule, I use my hand in such a way that my thumb, first finger means that middle finger and second finger, all of three are perpendicular to each other, and thumb indicates the direction of movement of wire. If my second finger is in the direction of magnetic field, and my middle finger points in the direction of current. When I use my hand and arrange in such a way that thumb, second finger and middle finger are perpendicular to each other, then I point my second finger in the direction of magnetic field and middle finger in the direction of current. Then my thumb indicates the direction in which the wire XY is moving, and it is moving to the top of page. So the direction of movement of the wire is to the top of page. So I write here we have to take the answer. So it is last one to the top of page. We also have to explain. So I write here current, magnetic field, and direction of motion, that is motion, are mutually perpendicular. Current is flowing into the page. And the magnetic field is from left to right. Part C. Statement is observed on the emitter when the wire XY is moved. Part 1. In the opposite direction to part B. Here we have moved the wire in the opposite direction. First of all, going back to the diagram. So here the motion of the coil, the motion of the wire is top of the page. But in this part we have reversed it. It moves in the opposite direction, then the direction of current will be opposite and there will be the deflection on ammeter which indicates that current is flowing in opposite direction. So I write here opposite deflection on ammeter. Part 2. In the same direction as part B but at a greater speed. No, we have increased the speed. By increasing the speed there will be more current through the wire and the deflection on ammeter shows the greater rating of current. So I write here greater current. Question number 8, part A. Define electromotive force EMF. What is electromotive force? If I consider it's a battery and it completes a circuit and current is flowing through this circuit. Current is basically the flow of charges. So the work done on these charges to move around the whole circuit is actually the EMF. So I write here EMF is equal to work done over charges. So the work done on charge to move it around a complete circuit. It is called electromotive force. Part B. Figure 8.1 shows a source E of EMF whose EMF is 60 volt in a circuit. So here is E and its EMF is given that it is equal to 60 volt. The heater H has a resistance of 22.5. Here H is heater and its resistance is 22.5 and the potential difference across it is 45 volt. So here across the heater V is equal to 45 volt and its resistance is equal to 22.5. Part 1. The power of the heater. We have to calculate the power of heater. We know that power is equal to I and V, the product of current and potential difference. But here we don't know the value of current, and then we use Ohm's law. V is equal to IR. From that we find the value of I. I will be equal to V by R. I put this value of current in this equation and it becomes V square over R. And V is given 45 and the value of resistance is 22.5. I am putting here 45 square divided by 22.5 and power comes to be 90 watt. So the power across the heater is 90 watt. I write here power is equal to 90 watt. Part 2. The potential difference across resistor X. So here we have to find out the potential difference across X. We know that this resistor X and 10 ohm resistances are parallel combination. And first of all, we have to calculate the potential difference across this parallel combination and then we find out across X. And in the whole circuit, there is potential difference of 60 volt and 45 volt consumes across heater. The remaining potential difference will passing through this parallel combination. So I write here the potential difference across X will be equal to 60, that is this one, E, and I have to subtract it from 45. So it becomes 15 volt. Now this 15 volt is a potential difference across 10 ohm and X. And both of these are in parallel combination. We know that in the parallel combination the potential difference remains same but current is changes. So here the potential difference remains same. It means that the potential across X is 15 volt and also the potential across 10 ohm resistance is 15 volt. So I write here the potential difference across X is equal to 15. In the part 3, the current in 10 ohm resistor. Here we have to find out the value of current. Going back to the circuit. Here we can see that the value of resistance is 10 ohms and the potential difference across this component is 15. And here we have to find out the value of current. I use Ohm's law. V is equal to IR and I is equal to V over R. V is 15 volt and the resistance is 10 ohms and the value of current will be 1.5 amperes. That is passing through 10 ohm resistance. So I write here the current will be equal to 1.5 amperes. Question number 9, part A. Write down the truth table of OR gate. Here we have to write the truth table of OR gate. In OR gate, when any one of the input is high, the output will be high. So I write here in OR gate, when any one input is high, output will be high. So when I have to draw the truth table, first of all I draw a table. we have two inputs and a single output. So there are four combinations of input. I will write it as I considered it as A and B are inputs while X is output, and it will be equal to A or B. So first of all, inputs are 0 0, then 0 1, 1 0 and 1 1. So in the OR gate, from this statement that in the OR gate, when any one of input is high means it is 1, the output will be 1. So it is 0 0 means that output will be low, it is 0. Here it is 1, that is high input, the output will also be equal to 1. So 1 and 0 also give 1 because 1 input is high here, and in the last combination both of the inputs are high. So the output will be high. I write here 1. Part B. Draw the symbol for a NOR gate. NOR gate is formed by the combination of OR and NOT gate. When we combine OR and NOT gate, we get NOR gate. And what will be the symbol of NOT gate? I will draw here as so there are two inputs and a single output. It's a single output here and two inputs. So this is the symbol of NOT gate. Here A and B are inputs and output is X. But in the question we have to draw the NOR gate. That's why we also have to apply here NOT gate over OR gate. I just place a bubble sign here to represent NOT gate here. So I redraw this line. That is the output of NOR gate. It will be just like this. And this output will be equal to A or B. So this is basically the symbol of NOR gate. In the part C, we are given a circuit, and in this circuit, two inputs P and Q, and we have a single output S. There is a point R and there is also a gate at X. Part C. Figure 9.1 shows a digital circuit designed to produce the values shown in table 9.1 for the output S from the two inputs P and Q. Part 1. Table 9.1 is the truth table for the circuit shown in 9.1. So it is a truth table. Complete the column for point R in the table 9.1. Here we have to complete the truth table by putting the value of R here. So in the figure 9.1, we see that the inputs are P and Q, and this symbol is basically NOT gate. It means that we have applied NOT gate over input Q. So NOT gate changes 1 into 0 and 0 into 1. It is the gate of conversion. So it converts 1 into 0 and 0 into 1. So when the input is 0, I write here output is 1, and when input is 1, output will be 0, and it is 1 and 0. In the last there will be output 0 because input is 1. Part 2. State which type of gate is used for gate X. Explain your answer. So here we have to tell that what is the name of gate X. So first of all, the gate X is formed by inputs P and R. It is P and this is R. This gate X is formed by the input P and R. In the table we have see the values of P and R and tell what is the type of gate that is used at the place of gate X. So first of all, I draw the truth table for AND gates. So again there are two inputs. Here is P and R used. I also use P and R and S. First of all, here is 0 and input of R is 1. Second combination is 0, 0 and 1, 0 and 1. It is third one combination is 1 and 1. And last one is 1 and 0. So here is 0. At the 0, 0 it is 0. Again it is 1 here and it is 0. So we saw these inputs and outputs. When both inputs are low, output is low. When both inputs are high, output is high. And when any one of the input is low, the output is low. We can simply say that the output is high only when the input and output has high values. And this gate is basically AND gate. So the gate that is used at the place of X is AND. So I write here in the explanation that when inputs are 1 and 1, the output is 1. When any input is 0, output will be 0. So number 10, part A. State the proton number, nucleon number and the value of charge on an alpha particle. So first of all, what is alpha particle? These are helium nuclei. So I write here alpha particles are helium nuclei, and here we have to tell the number of protons and nucleon number and charge on this. So number of proton, basically this is number of proton and it is the atomic number of helium. So here number of proton are 2 and the nucleon number is the sum of number of protons and neutrons, and this 4 represents the atomic mass, which is the sum of proton number and neutron number, and it is equal to 4. So the nucleon number is also equal to 4. I write here proton number is equal to 2 and nucleon number is equal to 4. And also have to Tell the value of the charge on alpha particle, as alpha particle is made up of 2 protons, so the charge will be +2. Part B. A nucleus of strontium-90 consists of 38 protons and 52 neutrons. Strontium-90 is a radioactive and decays by beta emission to an isotope of yttrium. The symbol of strontium is Sr and the symbol of yttrium is Y. Write down the nuclide equation for this decay. Here we have to write the equation, and there is a strontium whose atomic number is, number of protons are 98. Number of protons are 38. So 38 basically is the atomic number here. I write here 38. That is atomic number. And we also have to calculate the atomic mass. Atomic mass from this formula, it is the sum of number of protons and neutrons. Here number of protons are 38 and the number of neutrons are 52. So I add 52 and 38, it becomes 90. So the strontium has atomic mass 90 and it is a radioactive element and decays by beta emission. Beta particles are just like electrons. So I write here, it emits electron 0 minus 1, or it is beta particle, and it changes into another particle which is yttrium, and its symbol is Y. We have to tell that what is the atomic number and mass number of Y. So for that we have checked the atomic number and atomic mass on both sides of this equation and balance it. First of all, on left hand side and right hand side, I check the atomic number and it is represented by Z. Here atomic number is 38. Here it is minus 1. So I write here 39. So that 39 minus 1 is equal to 38. So the atomic number is 39. I write here 39. And also mass number, it is represented by A. Strontium has 90 and here electron is 0 plus 90. So that 90 plus 0 is equal to 90. The atomic mass of yttrium is 90. So it is the balanced chemical equation for the decay of strontium into yttrium and electron. Part C. The half-life of radium-220 is 56 seconds. A sample of radon. Part C. The half-life of radon-220 is 56 seconds. A sample of radon-220 is in a container. After 1/12 second, the mass of radon-220 is 9.2 milligram. Calculate the mass of the original sample. Here we have to calculate the mass of original sample. So first of all, half-life is the time during which half of the atom of the radioactive element decay. So here half-life is 56 seconds. If I consider that it's a mass and it's a radon and its mass is, we have to calculate its original mass and I label it with X. After 56 seconds, when one half-life passes, its mass reduces and it becomes half. It becomes X by 2. And in the next half-life, when again one half-life passes, it will be 56 seconds multiplied by 2. So it is 1/12 seconds. Then its mass becomes X over half of this value. So I write X over 2 and I have to take half of this value. It will be X over 4. So this is the mass of radon and its value is given 9.2 milligram. It is equal to 9.2 milligram. We have to calculate the value of X, that is the initial mass. So first of all, we calculate the total number of half-lives. I write here total number of half-life, it is equal to total time divided by half-life. Here total time is given in question is 1/12 second and half-life is 56 seconds. So it means that 2 half-life passes when the mass reduces to 9.2 milligram. So we can easily calculate from here the initial mass that is represented by x. So from this equation I just multiply 4 with 9.2 and it becomes 37 milligram, which is the mass of radon initially. So I write here mass will be equal to 37 milligram.